So, welcome back to today's class lecture. Yes, I think we've come a long way. We're on lecture 7, and then we are almost finishing up and then wrapping up. I think today, my apologies for coming late. Yes, a little bit tight in here, but I believe we can do some one or two things, okay, before we leave for today, because we can't waste the hour just like that. At least we can do a lecture or even two before we leave in here. I just mind we have left with only three lectures, okay? So after this, I think it's left with the last two, okay? So we will start. All right. So starting, we are praying, okay? We are praying in the name of the Father, in the name of the Son, and in the name of the Holy Spirit. Oh Jesus, we invite your presence, we invite your spirit into our midst, into our meeting. You are the one that, oh Lord, who started with from the beginning till this very portion that we haven't ended yet. But we know you've done a lot for us. We know you've helped us from that time till today. We pray and we say, may your spirit, O Lord, bring to us understanding. May your spirit bring to us wisdom. May your spirit bring to us, O Lord, enlightenment, O Lord, with knowledge. And may all things be done, O Lord, to your glory without any strife. In Jesus' name we pray with thanksgiving. Amen. All right, so we will take off, okay, from where we ended yesterday. I think yesterday we ended with a part of the schedule management. I think this is lecture 6C, okay, lecture 6C, lecture 7. That's the last part of the schedule management, okay. So let's take this and then let's finish it. Okay, I want to share this as a full screen. I think where we've gotten to so far, I think we have a lot of readings to do, so we must just understand some few things from it. Okay, yeah. Okay, so in today's session, we will continue schedule management processes. Okay, so we are to estimate activity. Remember that for the schedule management, we started with defining work breakdown structure. Okay, defining work breakdown structure, and now we will come to estimating activity resources. I think no. Secondly, we will do our scheduling. Okay, we schedule activities. That is the two. So first of all, we define work breakdown structure. That is the that is dividing the project into into models. Okay, and then sharing them. Okay, among people. Okay, who are available, who are also in agreement to take on the project. And then secondly, we schedule the activities of the work breakdown structure. Okay, so the division that we've made, we have to allocate time, resources, and then and then effort. Okay, to it. So that is what we just finished with. So what we are going to look at today will be um estimating activity resources, and then estimating activity duration, and then developing the schedule, and then controlling um the schedule. Okay, so just also know that after this particular lecture, the next thing we are to look at is cost management. Okay, that is why you can see cost management right from here. Okay, so give me just 30 seconds. I want to just set up this application, and then then we move on. Okay, so um as I told you about, okay, the schedule management or the time management processes has creating creating work breakdown structure, and then what defining what activities. Okay, after you what you sequence the what the activities, that is the what the arrangement of the activities, and afterward you estimate the activity resources, and then you what you estimate what activity durations, you develop schedule, and then you control. So this is the what the breakdown. This is what you define the what the breakdown that should be done. Okay, so let's assume what if you divided the what the project into 10 parts, you have to define every part. I mean maybe the part one. This is where what we will need what people to come on board to what, invest in the project. Maybe part two. That's where maybe what we have to what to gather whatever elements we need in what in building the project, and then what work needs to be done. Maybe part three, that is the definition. Sequence activities. This side means that what how are we going to be what arranging the parts of the project? Maybe part two must come before part one. Okay, we are scheduling, or we are what we are sequencing. Okay, maybe 10 must come before maybe one. That is what it means in here. We must do something before the other. And then we come to what? Estimate what? Activity resources, okay? We must estimate, okay, the resources, okay? We should find out the critical activities and not allocate resources to. And then we have to estimate activity duration, okay? The durations what allocated to each okay, Faith. I see. Light out. Wow. Hmm. Okay, it's on record. It's on record. Okay, and then you allocate time to the activities. Okay, and then the sixth one says what? Okay, you work up. The sixth one says what? You develop for the schedule. Okay, and now you can control the schedule just in case. All right, so let's see. So estimating what activity resources before estimating activity duration, you must what, have a good idea of the what, of the quantity and the type of resources that will be assigned to what, each activity. Okay, so before what, you estimate what activity duration, okay, you must what, have a good idea of the quantity and type of resource that what, will be assigned to each activity. You have to what, consider important issues in estimating what resources. Consider what important issues in what estimating resources. Okay, how difficult will it be to do specific activities on this project? Okay, how difficult, okay, will it be to do a specific activities? Okay, yes, you have to what, consider all of the what important what issues before what you estimate resources. Okay, maybe let's see, maybe there is a particular what part, a particular point in the activities that may be very difficult to what, to utilize or difficult to do. So we must not what take or give what a blind eye to it. We must tackle it. Okay, that is what how difficult will it be to do specific what activities on this project, and then what is the organization's history in doing similar project. Okay, let's assume you want to do a project for the organization. Maybe in the last 5 years they tried doing what a similar project, but it failed. Okay, so history sometimes what repeats itself. So you trying to what come in the organization and what maybe organizing or maybe saying you want to build on this particular project, you need to what, refer back. You have to find out. Okay, if you find out and you realize this is what happened, then what you re-strategize. So you know because you don't want the project to also fail, you are going to what find a way and what and a means what to make sure the project succeeds. And then there are also what required resources available or need to be what to be required. Yes. Then there must be what some resources available. Okay. The question is, are the resources available? Is the money available to start the project? Are the people or people with skill available? Are we agreeing on the same thing? Okay, so if the need be, these are required. Okay, so techniques for what? For resource estimating. Okay, we want to what? Estimate what resources. These are some of the techniques. Remember that in software engineering, okay, we did what? Estimating what a project. If you remember, that is why you remember we use this what expert judgment. We use yes, if you remember, yes, it says yes. We also used what we used pet in doing that. I think we even used Kokomo. Yes, Kokomo in what in doing that particular project. Okay, and then sometimes what we looked back to what project people also did. So in here. It is techniques for what? Resource estimating, okay? It says what? One is expert judgment, okay? That is what? To gain insight into the resource requirements for each individual work package. Okay, expert judgments mean that maybe we need to get what? At least 3 or 4 people, maybe who are experts in the what? In the field, okay? Maybe they've worked on a particular project, okay? So maybe they can give their what? Their opinions on the project because they've worked for a very long time in the industry. So they can what? They can help. Then we have another one we call it analogous, okay? We have what? Analogous. Okay. This is what? Using what? A similar project first and then editing to fit the uniqueness of it. So analogous means that what? The project that what you are working on. Get what? A different project which also looks like it. Okay. So you are going to compare your what? The current project that you are having to the what? To the old project that what you've seen. And then what? You compare and what? And you contrast some things from it. That is what we call what? Analogous. So the third one says what? Alternative analysis. Okay. Alternative analysis. That is what each work package will have what? Alternative ways in which the work can be what? Accomplished. Some examples include what? Different skill levels of resources, internal versus external resources, technology selected, and time what? Constraint. That is what? Alternative analysis. Okay, yes, maybe some people are in the organization, they can help do something. Maybe we can outsource people to come and do. Maybe sometimes it depends on the application of technology that we are using, and then sometimes the time. That is what alternative analysis. So we have what expert judgment, analogous, alternative what analysis. All right. So step 5. Okay. Step 5. So step 4, we've done what estimating what estimating the activity what I think we did estimating the activity what resource what estimating activity resource, right? Yes, activity resource. So 5 becomes estimating activity duration. So after we define the what the activities, we determine their sequence. As I explained, we assign appropriate resources. The next step in the what in the schedule management is to what estimate what activity duration. Okay. Okay, so let's look at this. So it says what duration includes the what the actual amount of time worked on an activity, okay, which means how many hours was used to work on what a portion of the project. Okay, that is what the actual amount of time worked on an activity plus the elapsed time, and then what time is what is remaining. Okay, yes, how many amount of time that has been what has been used, and then what's the remaining time to complete the project. Effort is the what? Is the number of work days or work hours required to complete the task. So what effort do we need to complete? That is effort. Effort is the what? The amount of time or the days that is what required to complete the task. Effort does not normally equal duration. Effort does not normally equal duration. People doing the work should what help create estimates and an expert should what review them. Okay, so whoever is doing the work should also what contribute in what helping create what estimates, and an expert should what review the estimate so that it doesn't go out of the or maybe outskirts, okay, of the whole scope that what we are working around. Okay, so to arrive at an estimate of time, you first what determine which estimate of work size is needed. Okay, to arrive what at an estimate of time, you first need to know the what. Yes, it's the same thing. Maybe when I give you what, maybe a park, and when I give you a stadium to be maybe to build, you are going to know that what a park is not what that bigger than a stadium. So maybe there will be what limited or maybe some few maybe days that maybe you allocate. But at the moment you get to the stadium, because it is big, because of the size, maybe you may say maybe 2 years or maybe 6 years. Okay, that is it. So you must what? You must first what estimate the work size of the project before what you give time to the project. As Capes Jones, okay, he points out the first step in what accurately estimating a project is what determining what its size. So to estimate a project, you have to what determine its size. You have to point out that this is the size of the. It is big, it is small, it is medium, it is this, it is that. That is the first thing to always do before what you estimate what you estimate or you give what duration on a project. Over the years, many different techniques have been used. Okay, including what? Functional points or function points, feature points, okay, lines of code. When we talk of what function points, okay, function points simply means what? Okay, let's say maybe you are having what? Uh, okay, let's assume maybe you are having what, a particular what, program. Okay, maybe I'm just trying to maybe just use this. Okay, maybe some kind of what, functions in the what, in the program is what is going to be used to determine the cost of the what, of the program. You have what, feature points. Okay, maybe the features are the lines of code also what, the lines of code. Okay, maybe we count. You have what, 1,000 lines of codes. 2,000 lines of codes is going to pay you maybe $100. So and so. Okay, these are also what used to what, are techniques used to what, to estimate what duration. After the effort has been sized using one of these methods, okay, time estimate can be what, can be applied. Let's see. Function point. Okay, function point is used to what, estimate time and monetary resources. It is used to estimate time and what, monetary resources based on the generated system requirement specification. A function point measures the size of a business function. Okay, it measures the size of a business function that the new system needs to have, such as what, an input screen or what, or a report. Okay, so we need what, a particular function in the new system, such as the what, an input screen or what, or a report. Okay, so function point analysis can be done at any point in the project, but are not considered accurate until late in the planning phase. Okay, they can be done at any point in the project, but are not considered accurate until late in the planning phase of the project. Okay, so this is what, an example of what, function point. This is what, complexity calculation. Just know we have categories. We have user input, user output, user inquiries, files, and what, and structures, and then we have what, external interfaces. Okay, the number of low, this is the width. The number of average, this is the width. The number of high, this is the width. So we multiply what, the low times the width, average times the width, high times the width, and then we add them together. We get 98. Just see this. 22 times 3 is 66. 5 times 4 is 20. 66 plus 20 is what, 86. 86 times 12 is what, 98. So you what, you multiply this and that. Each particular one of the what, of the attribute that is what, of low with the what, with the weight, average with the weight, high with the weight, and then multiply, and then you add them together. And then what, you add them, you get the grand total. This is the what, complexity calculation. You made it somewhere, please. Don't say maybe you can't do it. It is very simple, as you can see. The low and the weight, average and the weight, high and the weight, and then total, and then what? You get the grand total. Okay, so tax sizing, that is lines of code. Okay, lines of code has been one of the most used methods throughout, based on historical result, based on what, historical result. Okay, effort. Okay, based based on what, historical result, effort, documentation, software backed, and what, and number of what, of resources. Okay, so based on historical result, effort, documentation, software backs, and number of resources. Okay, and what had come out. Okay, so advantages of what, of lines of code is that it it can be, it can be very quick and inexpensive to generate. It is very quick to use. It can be done early in the process. It is a universal metric. Okay, it is used mostly everywhere. That is a universal metric. And it can be generated easily in most environments automatically. It facilitates what, a lesson learn process. Okay, yes. Okay, the reason why we say this, facilitate a lesson learn process, is that what, sometimes maybe what should be considered as a code, that's what we count. So that is the sense, maybe you learn your lesson that maybe this particular side or maybe this particular thing is what, auto generated code. We don't count. So maybe yes, it gives you some lessons to learn so that you write your own code. All right. So disadvantages of what, of lines of code. Okay. It must what, compensate for technology differences. Okay. It must what, compensate for the different, because maybe we may be using what, different technologies. Okay. Let me see, maybe I'm writing what Python code, and then you are writing maybe Java code. Just imagine, you Java, you write 1,000 lines of code, and then Python, I write 10 lines of code. But the code is doing the same thing. But we are supposed to pay the same amount of money. But because of we are saying lines of code, meaning what? The Java man might take $100, and then Python man might take only $1 because his lines of code were just 10. Java wrote for 1,000 lines of code, but doing the same thing with the Python. That is what one disadvantage. Okay, so it must compensate what for technology differences. That is what this one means. And then this one says it can't be done well unless relevant history what exists. Yeah, so this one also depends on what on history. What happened maybe last year, last 2 years, last 5 years. If there is no history, meaning what? It is impossible to use lines of code. And then it must determine what counts as a line of code. As I told you guys, okay, what counts as a line of code. The reason I'm saying this is that auto generated code might not be counted because that was what generated by the what by the IDE or so and so. Maybe when you write maybe a code that has maybe 5 lines, or maybe a code that has maybe 5 words or 5 elements, maybe that is what they count. But maybe telling you to write maybe 20 pages, they will say that what the images what you place in the document is not part. So make sure that what only your writing is 20 pages, so the images are different pages. That is what they count. Okay, maybe you write for 100 lines of what I will go to school, I will go to school, I will go to school. All right. Yes, that is what they count. But if you write less than it is not. So it must determine what counts as a line of code. And then this one says what level of resources generating the code? What level of what resources is for generating the code? And then it has no industry standard. Okay, there is no standard in the industry for what lines of code. And then it needs to to distinguish between auto-generated code and what and original work. Okay, we have to, because some people might not, since AI is now in existence, so we can also generate code, and then we bring it out or we wrote the code here is it needs to distinguish between what auto-generated code and what the original work. And then it needs to be what continually what updated, since what it depends on what on existing what history. Okay, so these are what disadvantages of lines of code, but advantages too are there that it is quick to use. Okay, it can be what done early. It is a universal metric. It facilitates what a lesson learned process. Okay, but these are what disadvantages. Okay, so techniques or what for estimating what activity or duration. Okay, yes, still continuation. Okay, still continuum. This one says that what system analogy. Okay, that is what I told you. The analogous, meaning what the current system that we are having must be compared to what another system somewhere. But we should make sure that other system somewhere has what something like what similar features of the new current system. So when we compare and we contrast, we can be able to to estimate what the duration, okay, based on the what on the older system that what we are comparing. Okay, so we have what top down what estimate, and then we have what package level or what or bottom up what analogy. So we have also 3 points or what we call the PET. That is what program, evaluation, review, technique. Okay, that is PET. It is used in what estimating what activity duration, and then we have one we call the okay. So with the PET, okay, the reason why we have PET, we say what we say 3 points is that it has what 3 points. Okay, sometimes it puts what first point as maybe the low, second the medium, and then third the high. Which means if we miss the low, we won't miss the medium. If we miss the medium, we won't miss the high. So within all of these 3 points, the project is going to be completed in such a way that yes, we are not going to miss anything. Meaning maybe if the project should finish maybe in 1 year, okay, they're going to divide it maybe in maybe first 5 years, second 7 years, and then the third one might be what? Might be the 1 year. That gives us what a 3 point. Okay, then we have what we call the simulation. That is what? That is Monte Carlo. Okay, Monte Carlo is the what? Is a simulation that what? In here, we are going to what? It is based on software. Okay, so the software is going to take what? The project, maybe two projects, and then it's going to simulate it in a graph like a bar graph or a bar chart. So you are going to see how what? How it raises up. So you are going to just compare and then you contrast and then you know that's what okay, this is the time estimation. Okay. Then we have what we call the COCOMO cost. Yes, COCOMO. Okay. I think it's something cost model. Or say I think it is cost. You I think we'll find it. We'll find it. COCOMO is also here. It is a parametric what model. You remember COCOMO with it? It was in a table. It also has weight. Okay. It brings what the features or what some particular what points of the application, and then what we multiply and then we do some calculation. That is COCOMO. So it says what system analogy bases a current work package time estimate. Okay, as I said, it bases what a work package of what a current work. Okay, on the actual time of what of a package from a similar project already. So we compare the what two projects. Okay, and then what we estimate the time. Okay, it is usually done in our top-down approach. Have a 3 or 4 experts review requirements, and then you make sure you have the what, experience and that the two systems are what are very similar, as I told you, and can use time or function point as well. And then we have what the package level or the bottom up analogy from the same what system analogy, right? It involves what estimating what individual work activities and summing them to get what a project total. So what we add up the small activities to get what the whole total of the project, and then each person assigned to that work activity, that's the estimate. So if maybe we are 10 people, we've been assigned to 10 tasks, each one of us are going to what are going to estimate what our own what assignments. Okay, and then it can be what time intensive to develop. It can be what time intensive to develop, and then it is dependent on what on each individual's ability to estimate. Because if we are 10 and then we are estimating, maybe the guy who is what at the first point is not really what matching up to what to his expectation or what estimating the project, then meaning what we the 9 we know we are done, but we are still what waiting for that particular guy. So it is individual dependent, and then combining what several independent estimates. Okay, combining what several independent estimates yields what a better estimate. Combining several independent estimates yields a better estimate than what than separate estimates. Okay, so we have to combine everything than we what maybe yielding one after the other, one after the other, one after the other, and then errors are what are randomly distributed. Okay, statistically what speaking. So this is what package level or what bottom up analogy. Okay, yes, the package level or what or bottom up analogy. Okay, it estimates what individual work activities, and then what we sum them up to get a total. Okay, and then we have to what combine what several independent estimates to get what a separate what estimate. It can be time intensive to develop, and it depends on what individuals what abilities were to perform estimations. Okay, 3 point estimate. Instead of what providing what activity estimate as what as discrete number, such as what 4 weeks, it's often helpful to create a 3 point estimate. Okay, so that you just don't go there and say that I'll finish the project in 1 year. No, just what create what a 3 point estimate. Okay, an estimate that includes what an optimistic, most likely, and pessimistic. Okay, optimistic is the what is the lower point. Most likely, maybe. So let me say, optimistically, I may finish the project in what in 4 weeks, but most likely maybe 6 weeks. Pessimistically, maybe what 10 weeks. So what you schedule it that way, then you know that's what by all means the pessimistically part, the last part, the 10 weeks next year, the project will be completed by that time. Even though you may be able to finish in the what in the optimistic. Okay, yes, that is good. But just in case maybe what you miss it, meaning what most likely should come in. But if maybe most likely doesn't also cover up, then meaning what? Yes, there is no way you should cross what pessimistic. Okay, such as what 3 weeks for what for the optimistic, 4 weeks for the what most likely, and then 5 weeks for the what pessimistic estimate. Okay, so 3 point estimates are needed for what PET and Monte Carlo simulations. So please take note. PET, Program Evaluation Review Technique, and Monte Carlo simulations are what, 3 point 3 point estimates. Okay, so 3 point estimate continued. Okay, use what, a weighted average approach or beta probability distribution approach to capture the 3 point estimates for each work package. Okay, that is what, optimistic, normal or most likely, and pessimistic. The equations for expected value, that is E is what, expected value, and the standard deviation, that is what, SDR. So these are what formulas that what you should know. Expected value is equal to what, A plus what, 4B, okay, plus what, plus C, all over 6. Standard what, deviation is what, C minus A over 6. So please just know that A, B, C are nothing than the what, optimistic, normal, and pessimistic. Okay, it's nothing. A is what, optimistic, B is what, normal, C is what, pessimistic. So even if it is a question, I'm going to give you what, optimistic, normal, and what, pessimistic. So you have to what, to put it in the what, in the formula. A plus 4B plus C over 6. C minus A over 6. Okay, so that is standard deviation is what, optimistic minus pessimistic over 6. Expected value is what, A plus 4B plus C over 6. Okay, so let's have a look. So a simple question or a sample question. Weighted average is equal to what? 8 working days, that is what, optimistically. 10 working days, that is what, that is normal. 24 working, that is what, pessimistically. Okay, so you see this? Yes. So then we what, put in the formula. So we are finding for the what, expected what? Expected value, or the expected what? Estimate. Okay. Therefore, you would use 12 days on the schedule instead of what? 10 when using this particular what, technique. Okay, so most likely was what, was 10, but after what we use the formula, we realize that what, no, it should rather be what, 12 days. Okay, so program what, evaluation and review technique, that is PET. PET is a network analysis. Okay, PET is a network analysis technique used to what, estimate project duration when there is a high degree of what, of uncertainty about the individual activity duration estimate. So that is used when what, there is individual what, uncertainty. Okay, when there is what, high degree of what, uncertainty about the individual activity duration estimate, that or maybe individually the people may not be what, may not be calculating or may not be what, estimating their durations what, well. So that is where what, PET comes in. So PET weighted average is also the same thing. Optimistic times or 4 times what, plus 4 times most likely time plus what, that's the same formula as you saw here. It's the same thing that we are using for the other. It is a 3 point evaluation. Okay, 3 points for evaluation. Okay, so this is sample question again. What day should be included for the following activity? We have optimistic is what is 8, most likely is 10 days, pessimistic is what is 24 days. So we have this, we have that, that is 12 days. Most likely was 10. Instead of 10 days, it was what, 12 days. Okay, yes. So that is that. So this is what, simulation. Monte Carlo. I told you that what, we get the what, the project right, and then what, and then we simulate. Okay, this is a technique that's randomly what, generate specific end values for a variable for a specific probability distribution. Okay, so we simulate and then when we check or what, when we look at the what, at the project completion time, maybe what, estimate the what, the duration for the project. So Monte Carlo is based on what, on simulation. Okay, constructive what, cost model, that is COCOMO, constructive cost model. It was first developed by what, Barry Boehm. You remember that thought in software engineering, I think they asked us to write the what, some of the rules of what, Barry Boehm. He asked us to write, I think, 4. Yes, I remember very well. Celsius intro for Barry Boehm, what, either his theories or what, or his laws or whatever. And then most widely accepted models available today. It was revised into 2 versions. Into version 2 in 1995. Okay, version 2, version 2 set up to handle new development methodologies like rapid application development. What does this one mean? This one is just like what, making an application what, faster and quicker without wasting more time, like the way we make what, VB applications. Okay, we use what we call RAD, rapid application development, right? So you can make the application very quickly. Not that way you have to go and write a lot of code. You have to guess what technologies, and then we add in, be combining maybe HTML, CSS, Java, and then the whole that is just RAD, rapid what application development. We have iterative or incremental. Okay, iterative means that what when we are making the system, okay, when we make maybe sprint, we make sprint, we divide it into maybe sprint one. We have to develop the sprint. Afterwards, we do it. We show it to the stakeholders and the people involved in the project. When they agree that what they want this particular sprint, then we continue to sprint two. But if they don't agree, that is what we come to do it again. That is what iteration. So we go back and then we come back. We go forward, we come back. If they agree, we move to a sprint two. That is what the iterative and what an incremental. And then we have what cuts. Okay, and then this is what off the shelves. Okay, I think yes. Carmen, let me check out this um a minute. Yes, so this is what commercial what off the shelf. Okay, commercial off the shelf what, packages or application. Okay, that is also what a software that is commercially produced and sold in a retail store or online. So these are what closed source applications. Okay, these are software that we sell online or maybe in stores. Okay, it is ready to use without any form of what, modification by the user and accessible to everyone. And then we have what? Object oriented application distribution. Okay. The OO is what? Object what? Oriented application what? Distribution. Okay. And then we have what? Frameworks and what? And components and etc. So version 2 of Coco, okay, handles what? Some of the what? Software methodologies. Okay. Okay. So models available on websites and algorithms are published, and then commercial software what also what exists. Okay, so Kokomo consists of what, three project types described as organic, semi-detached, and embedded. Okay, so organic is that what small project teams. Okay, little innovation, constraints, and what deadlines are few. Okay, so small project teams, little innovation, and constraints and deadlines are few. Stable development environment, known familiar technology, and then what few changes are what are expected. Okay, so organically, Kokomo okay uses what small project teams. Okay, with little innovation. Maybe they may not have the what the resource. Okay, so that is it. We don't want to get what too much of what innovation that maybe we may not what get the resource to really what service the what the project. And then there is what constraints and deadlines, which are few because what innovations are few, then deadlines are also going to be few. Okay. There is stable development environment because what there is no much what high what innovation. Okay. And then few changes are what expected in the project that so maybe we may be changing some few things maybe after we are done or something like that. But a semi-detached, okay, semi-detached what part of the Kokomo, it is medium-sized project teams which are expected. Some innovation, some, okay, and then few constraints, as tighter deadlines, and more changes expected. Still a fairly stable development environment. However, the embedded has the largest of the three in all categories. Large project teams, constant innovation, many constraints, very tight deadlines, and many changes expected many changes expected, and then what complex development what environment. Okay, so these are the constituents or the what Kokomo consists of: organic, semi-detached, and embedded. This is for small teams and small project, medium-sized project, and then what high or bigger what project. Okay, Kokomo levels. Okay, early application. Early application. We have what early design, and then we have what post architecture. So with the early application, it is used mainly for office type applications. Used what mainly for office type applications. After completion of the analysis phase, assumes high level. Okay, early application. It is used mainly for what office type application. After completion of the analysis phase, assumes high level language. The early design. It is limited version of the application intended to be used prior to any architecture analysis and relies heavily on function point analysis. Post architecture. It is used to get a view of the project cost once an initial architecture is in place, but prior to detailed design. Then most used model original. So Kokomo is the most post architecture is the most used model against all of these levels. Okay, so early application is what is used for office type of applications. Early design is what is application that are limited. Okay, limited edition. Okay, maybe we have some that has a lot of maybe premium edition, but this is limited version of the application without no or much features. And then we have post architecture. It gives us a view of the of the project cost. Okay, and then Kokomo advantages. It can be quick. Okay, can be done early in the project. Same as the I think same as as the first one that we did. Okay, the first one that we did here. I think it also can be like the lines of code. Yes, lines of code. It's also quick. It can be done early in the project. Can be tailored to fit any organization. Can be applied at different phases of the life cycle, and many models exist to aid organizations in in getting started. Okay, these are advantages of Kokomo. And then the issues or disadvantages of Kokomo, okay, says that ignores documentation and other requirements. Okay, ignores documentation and other requirements. And then no compensation for customer attribute. That is availability, their knowledge, and their cooperation. And it ignores personnel turnover issues. Okay, whenever maybe we turn up a lot, many people comes to work on the project. Yes, because it what is stated a particular amount of maybe people is needed or particular something that it needed. It is not going to change anything again. It's not going to change anything again. So it ignores turnover. Okay. And then it is based on historical data. The same thing as lines of code. It is based on historical data as well. And then it is used only to estimate a development effort. Other phases of the project, that is like planning, implementation, okay, are not also accounted for. So this is why Kokomo is disadvantage or the issues that we can find in. First of all, it doesn't have documentation or doesn't require documentation. It has no compensation for customer attribute. It ignores personnel turnover. It is based on historical data, which may be old. So typical problems with estimates in general. Developing an estimate for a large project is a complex task requiring a significant amount of effort. Okay, developing an estimate for a large project is a complex task requiring a significant amount of effort. Remember that estimates are done at various stages of the project. Okay, just know estimates are done at various stages of the project. That is progressive elaboration, meaning as we go on, we are still making estimates. As we go on making estimates, okay. Maybe as we are going on, maybe economic hardship. Ec- eh? Why? Ah, okay. So remember that. So the estimates are done at various stages of the project. Okay, that is what progressive elaboration. Okay, so as time goes, maybe when there's economic hardship, okay, it's going to affect the project. So we have to to review or we have to change estimate. Okay, so typical problems with estimate. Many people doing estimates have little experience doing them. Try to provide training and mentoring to people who will be doing estimates. People have a bias toward underestimation. Review estimates and ask important questions to make sure estimates are not biased. Okay, and then management wants a number for a bit or just to look good to superiors, not a real estimate. Project managers must negotiate with the project sponsors to create realistic estimate. Okay, So first of all, say that people are not expertise or don't have what experience in doing what estimate. And then people also have bias because some they feel like, oh, maybe this project we can finish it in maybe 2 weeks. But they haven't really done the estimation to know. So they underestimate the project and then now it fails them. Okay, so it says that what we should ask what important questions to make sure the estimates are what are not biased based on what you saw, based on your perspective. Management wants to what a number for a bit, or just to look good to superiors, not a real estimate. Project managers must negotiate with what project sponsors to create what realistic what estimate. Okay, so step 6. Okay, after what? After making the what, estimate, we do what? Step 6. Okay, that is what? Develop the schedule. And then step 7 is what? Control the schedule. So step 6, develop the schedule. He uses what? Results of other time management processes. That is activity definition, sequencing, estimating to determine the start and the end of the project. Also determines the plan start and completion date for each activity listed on the work breakdown structure. The deliverables from this process is called what? Project schedule. Okay, so tools used for what? Schedule development is what? We have Gantt chart, we have critical path method, we have PET, we have critical chain, we have what? Resource what? Leveling. So tools that we use for what? So remember, these are tools. These are tools and not method. Tools that we use. The methods are the Kokomo. Okay, we have PET again. Okay, we have lines of code. Okay, and then we have that is what the activity estimation. But in doing scheduling, okay, in doing scheduling, methods are two. Scheduling methods are two. That is what activity diagram, and then we have what precedence diagram. That is for the methods. But these are tools. Oh, please take these are tools. Okay, we have Gantt chart, critical path method, we have PET, we have critical chain, we have what resource leveling. Okay, so project scheduling tools. Scheduling of a software project does not differ greatly from scheduling any multitask engineering effort. As such, generalized project scheduling tools and techniques can be applied with little modification for software projects. Tools used in planning, estimating, scheduling, monitoring, and what reporting projects include Gantt charts and what and network diagrams. Okay, so it even mentioned network diagrams again. Meanwhile, there's a method. Okay, but okay, fine. Let's take it. Okay, so tools used in planning, estimating, scheduling, monitoring, and reporting project schedules include what? Gantt chart and network diagrams. So we have what? PET, program evaluation review technique. And critical path method is also what? A tool that we use to schedule project. And then we have PET and CPM provides quantitative, okay, they provide what? Quantitative tools that allow the software planner to what? Determine the critical path and establish most likely time estimate for individual tasks. Okay, yes, because CPM and PET can tell you the critical path. Critical path is the longest part of the project. Okay, the longest time that the project can complete. Okay, then they establish what most likely what estimate for individual tasks. Okay, so Gantt chart. Okay, as you know, Gantt chart. Gantt chart is the most popular resource scheduling tool and attributed to Henry Gantt. It provides a graphical representation of a project, showing project tasks as horizontal bar with length proportional to completion time of the task. As you know how the Gantt chart looks like, that is what this one says. It is a useful tool for planning tasks in a project and monitoring progress as the project goes on. Okay, Gantt chart do not show how tasks must be ordered as precedence, but simply show when a task should begin and what and end. Today, software packages like Microsoft Project are available to provide what functionalities that were previously non-existent. Example, showing task dependencies, non-working days, milestones, and what and etc. So this is a Gantt chart. Okay, this is how it looks like. Okay, so these are the activities as you can see from here, and this is the time, elapsed time. So meaning what plan and schedule is going to what take somewhere like let me say this is 15 days to finish. Await hardware delivery is going to take 20 days. Programming is going to take um 80 days. Installation of hardware is going to take what? Maybe 35 days. Convert files is going to take 60. So that is what Gantt chart. It shows the what? The start and the end of a what? Of a project. And then sometimes what? The milestones, and then this one says that what is it? Should be should begin, and then when it should end. But no precedence. Please, there is no order. Okay, as you can see, there is no order. See this one, and then see this. This is the third one, but see where it has ended. But this one finishes before this. Before this. Okay, so there is no precedence in the Gantt chart. And then yes, I think that is all. All right, so Gantt chart in what Microsoft project. So the same thing. Okay, yes, this is the start to the finish. Start to the finish, start to the finish, start to the finish, start to the finish, start to the finish. The same way that what we are seeing, right? Just because this is just in a software. All right, so it looks this way. Okay, so explain the Gantt chart. The dotted lines going down the chart marks the beginning of a major time unit. For example, tax 7 begins on the what? On the dotted line beginning June 29. So let's see. Tax 7. This is tax 7. Okay. This is the dotted line. As they are talking about, this is the dotted line. Okay. The dotted lines going down the chart marks the beginning of a major time unit. So that is what? Major time unit. Okay. A major time unit within the project. So, for example, okay, so there are there are 8 tasks listed downwards in the left column, and the blue bars to the right graphically show the length of each task. Okay, yes, the length of each task are showing the length. Okay, the arrows from the end of one task to the beginning of another means the second task. Okay, the arrows from the what from the end of what of one task. Okay, this one shows that what second task, third task, fourth task, fifth task, sixth, seventh, eighth. Okay, that's the arrows. The back lines in the blue bars indicate how much of task has been completed. Okay, so the back arrow. Okay, this one's the black one indicate the amount of tasks that has been completed in that particular activity. Okay, so this maybe this is 100%. This is full. This is quarter. This is what full. This is beginning. This is what the whole this one is what is half. So that is that. Then the black diamond indicates what the milestone. Okay, this black diamond, this milestone, milestone. Right, the milestone is a reach that what we celebrate. That also we've been able to reach here. All right, so benefits for using Gantt chart. The bar chart representation is easy to assimilate and understand. It displays activity progress very clearly and simply, and then it is a key document for the management decision making function. In its original form, the Gantt chart has two main shortcomings. Does not show explicitly the sequences and interrelationship between the activities. It lacks as a planning and control tool when multiple decisions need to be made, sometimes simultaneously, okay, before activities are placed on the Gantt chart. Okay, yes, it does not show explicitly the sequences and interrelationship between the activities. As we said, activity one can start and then seven can also follow up. It doesn't really have how should I say it? Okay, that sequencing that maybe after this one goes okay. So the one that we just saw here. Okay, that's what we saw a sequencing from the back. Just know that after this right that this one would go before this right because if you check maybe this one and this one are going to be the same way. Okay, yes. So we don't have to. This is not important. Okay, this is the software part. Okay, using the software is not important. This is not also important. Okay, so this says what using what software to assist in time management. Okay, using software to assist in time management. Software for facilitating communications helps people exchange schedule related information. Software for facilitating communications help people exchange schedule related information. Decision support models help analyze trade-offs that can be made. Decision support model, okay, help analyze what trade-offs that can be made. Project management software can help in various time management areas. Okay, let's have a look. Words of caution on using project management software. Many people misuse project management software because they don't understand important concepts and have not had training. You must enter dependencies to have dates, adjust automatically, and to determine the critical path. You must enter actual schedule information to compare plan and actual progress. Final note on project schedule development. It is an iterative process. Okay, we have to go back and forth, and then we have to review and revise the duration and resource estimate. Okay, because we said what estimate is what is like as we go on. Okay, we still do estimate. Okay, I think there was a word that was being used. Okay, I it is provisional or something like that. I saw a particular word, which means what as we go on, okay, we have to review and revise the duration and resource estimate. So you want to what create something that can get what approved. Approved schedule will then act as the baseline to track what progress. All right. So schedule control suggestions. We have to perform what reality checks on schedules. Okay. We have to allow for contingencies, and then don't plan for everyone to work at what 100% capacity all the time. In your plans, don't think what everybody will work what 100%. Hold progress meetings. As a good project manager, you have to be holding what frequent what meetings with stakeholders and even some of your workers. Okay, and be clear and honest in what and communicating what schedule issues. Okay, getting what schedule what issues. All right. So and then controlling the schedule. Right, that's the last thing. That's the seven or the eight of the what of the scheduling process management. Okay, goals are to know the status of the schedule. Goals are to know the status of the schedule. Influence factors that cause the schedule changes. Determine the schedule has changed and manage changes when they occur. Reality checks on the schedule. First, review the draft schedule or estimated completion date in the project charter. Prepare a more detailed schedule with a team, and then make sure the schedule is realistic and followed. Alert top management well in advance if there are schedule problems. Okay, checks if there's any problem, alert top managers because they have what higher say. Sometimes they can what talk to the the stakeholders for them to understand that okay maybe there was an issue which happened. Okay, then you make sure that what you follow the schedule and then you provide what a more detailed what schedule. Okay, and then you review and draft what the schedule or estimated completion date in the project charter. Okay, so that's what that brings us to the end of what of lecture 6 or what lecture 7 on what on scheduling management. Okay, so end this session right here. I think what our time is what is up. I think we said what we won't take what much time since we came very late. Okay, we have only what two lectures to what to complete on the project management. Probably, I believe tomorrow or today when we come. But today, I'm trusting and I'm hoping that what maybe if it is eight, we may start at exactly what 8 p.m. so that what maybe by 12 or what will be done with it and then what we do something what different. Okay, but so far so good. I think we are getting what something. Okay, from lecture 1, lecture 2, 3, 4, 5. We know the process groups. We know schedule management. We know scope management. Okay, then some of the few things what in there, and then yes, project itself, and then what goes in, what it entails. Okay, yes, we are not doing what bad at all, but I believe what it is going to be what to be well. Okay, so I would also wasting much time. Okay, I think we have about, let me say, if I should say, we have about just 50 what 50 slides or to complete the course. Okay, we have about just 50 to complete the course. So but maybe I know most of you are very tired to this particular point because of we coming this late. I will not waste much of your time maybe when we come back. Okay, but pardon me for today for coming late. Okay, yes. I think if there is no questions on anything, we'll end the class here. Then what? If God willing, we'll come back again in the evening. So till we meet again, the name is Kwame A Plus and I'm out. Watch out, peace, shalom. Bye bye.